question is on radius and interval of convergence of a power series. The complete interval of convergence of the series is what we need to find out. So whenever we have any series, so we can always find the interval of convergence using the formula limit n tends to infinity of your an plus 1th term divided by anth term. And this has to be less than or equals to 1. So here is what? From here, we can find the interval of convergence. So here in this sum, an is given as x plus 1 to the power of n over n to the power of 2. Yeah, instead of n, they have used just k. So in that case, this is going to be limit n tends to infinity of an plus 1 is nothing but x plus 1 to the power of n plus 1 divided by n plus 1 squared, and entire thing divided by an is nothing but x plus 1 to the power of n divided by n squared. Now, if I can also simplify this something like this, limit n tends to infinity. The numerator, I can also write it as x plus 1 to the power of n times x plus 1. And the denominator is n plus 1 squared, which can also be expanded. So which could be n squared plus 2n plus 1. And here, whenever I want to write this entire division as a multiplication, it has to be reciprocals. So n squared divided by x plus 1 to the power of n. Here, these things can get cancelled out. So in that case, those things can get cancelled out. So it's going to be, now in the denominator, I'm going to take n common out. So I'll be getting x plus 1 times n squared divided by, if I take n squared common out, not n, it's going to be 1 plus 2 over n plus 1 over n squared. Your n squared and n squared can get cancelled out. So in that case, now if I apply the infinity, all these terms will become 0 because 1 over infinity, 1 over any large number is going to be always 0. So that's why we will just get absolute value of x plus 1 is less than or equals to 1. So whenever we have this, we always say this x is between minus 1 to 1. So in order to get rid of this 1, I'm going to subtract 1 throughout. So that's going to give us x is between minus 1 to 0, minus 2 to 0. Now, whenever we get this, we should always check for the end points, whether at these points also it works or not. So when I substitute 0 here, so I'll be getting summation of k equals to 1 to infinity of 0 plus 1 to the power of k. So that's 1 to the power of k would be just 1. So 1 over k squared. So by the p-series test, this would converge for sure. So that means at 0, it works. Then if I talk about at minus 2, k equals to 1 to infinity, I'll be getting minus 1 to the power of k over k squared. And this one will also converge using the alternating series test. So that is the reason it converges both at minus 2 and 0. So that's why option E is the right answer for this sum.